Predictive policing. Predictive policing involves the application of mathematics, predictive analytics, and various analytical techniques in law enforcement to anticipate potential criminal activities. A report by the RAND Corporation outlines 4 main categories of predictive policing methods: predicting crimes, predicting offenders, predicting perpetrators' identities, and predicting victims of crime. Predictive policing relies on past crime data, analyzing times, locations, and crime types to guide police in optimal resource allocation and strategic patrolling. Algorithms are employed to detect patterns, signals, and potential crime spikes, facilitating quicker decision-making by considering various variables. This automated approach enhances effectiveness, allowing for data-backed predictions. The generated predictions are coupled with prevention strategies, directing officers to anticipated crime locations. By utilizing automated predictive policing, law enforcement can anticipate community concerns, allocate resources wisely, and prevent victimization. Additionally, data on shootings and gunfire sounds may be used to identify shooting locations, as demonstrated in Chicago through the integration of population mapping and crime statistics. Predictive policing, under the AI ethics of care approach, focuses on preventing crime by addressing environmental conditions contributing to higher crime rates in certain locations. Artificial intelligence is employed to identify and mitigate these underlying demands, aiming to minimize crime rather than solely predicting it. After the conclusion of violent combat operations in Iraq in April 2003, improvised explosive devices (IEDs) were strategically placed throughout the streets as a form of predictive policing to monitor and counteract U.S. military actions. However, the challenge arose when the covered areas were too extensive for Iraq to effectively respond to each American presence in the region. This led to the concept of actionable hotspots, areas with significant activity but too large to control comprehensively. Iraq faced difficulties in determining optimal locations for surveillance, sniper placement, and patrolling routes with IEDs, highlighting the complexities of addressing large, dynamic spaces with predictive policing strategies. Predictive policing in China has its roots in the policy approach of social governance, announced by Xi Jinping in 2016, aiming to achieve a harmonious and prosperous society through extensive information system use. This includes the development of the social credit system, digitizing identities, and quantifying trustworthiness. The Chinese police force collects and analyzes aggregate public and private information to understand past crime and predict future criminal activity, aligning with the government's goal of promoting social stability through informatization of policing. The Police Geographical Information System (PGIS) plays a key role, transitioning from public map services to exploring crime trajectory analysis and prediction. While there is no nationwide police prediction program, local projects in regions like Zhejiang, Guangdong, Suzhou, and Xinjiang demonstrate steps toward predictive policing. These projects involve real-time surveillance of online activities, collaboration with private companies, and innovative approaches like wastewater analysis for drug crime detection. China's Integrated Joint Operations Platform (IJOP) is a predictive policing system operated by the Central Political and Legal Affairs Commission. In Europe, there is substantial resistance to predictive policing and the broader application of artificial intelligence in law enforcement, both at the national and European Union levels. Despite this resistance, the Danish POL Intel project, utilizing Palantir Technologies' Gotham system, has been operational since 2017. The Gotham system has also found application with German state police and Europol. Additionally, predictive policing has been implemented in the Netherlands. In the United States, predictive policing has been adopted by police departments in various states, including California, Washington, South Carolina, Alabama, Arizona, Tennessee, New York, and Illinois. For instance, the NYPD in New York has introduced Patternizer, a crime tracking program aimed at assisting police officers in identifying commonalities among crimes committed by the same or similar groups of offenders. Patternizer helps officers save time and enhance efficiency by generating potential crime patterns, which officers can manually examine to determine if they are related to the current suspect. If a match is found, officers launch a more in-depth investigation into the pattern crimes. Predictive policing faces challenges that impact its effectiveness. Concerns include high costs and limited accessibility, hindering widespread adoption, especially in poorer countries. The reliance on human input to identify patterns introduces the risk of biased and potentially racist outcomes due to flawed data. Critics argue that technology can't predict crime but may intensify proximity to policing, with communities of color and low-income areas often being disproportionately targeted. Additionally, incomplete reporting of crimes leads to faulty and inaccurate data. In response to protests against police brutality, over 1,500 mathematicians supported a boycott on predictive policing in 2020. Some applications have targeted minority neighborhoods without sufficient feedback loops. U.S. cities are passing legislation to restrict predictive policing technologies and invasive intelligence gathering methods. Despite initial success in crime reduction, Santa Cruz, California, banned predictive policing in facial recognition technology, citing concerns about racial bias and discrimination perpetuated by these systems. Instances of facial recognition misidentifying individuals, such as in the case of Michael Oliver, highlight the technology's potential for errors, particularly on darker skin tones. Critics argue that predictive policing algorithms, influenced by biased data, contribute to the over-policing of minority or low-income communities.
Predictive analytics. Predictive analytics in business involves using machine learning to create models that predict future events based on current and historical data. It encompasses various statistical techniques, constituting a major subset of machine learning. In business, predictive models analyze patterns in historical and transactional data to identify risks and opportunities. These models capture relationships among multiple factors, allowing the assessment of risk or potential associated with specific conditions. The key functional outcome is providing predictive scores or probabilities for individuals, example, customers, employees, patients, influencing decision-making across various organizational processes, including marketing, credit risk assessment, fraud detection, manufacturing, healthcare, and government operations, including law enforcement. Police agencies are adopting proactive strategies for crime prevention, with predictive analytics playing a crucial role. By utilizing statistical tools to forecast crime patterns, police can optimize the allocation of limited resources and manpower. Predictive analytics of crime data enables targeted efforts such as directed patrol or problem solving to address crime hotspots, areas with significantly higher crime densities than the city average, leading to more effective crime prevention. Thank you for watching.